Okay, let's take a look at, this is video 2 on the OScope. And I know you can't see a lot of the details, but again, you should be using the video in front of the equipment as you're actually performing these same steps. So in reality, where are we? We are in the AC1 fundamentals module, and we're under the measuring with an OScope, and it's a procedure. So the first thing it has you do is set up your generator, your signal generator, with a 10 volt peak to peak at 1 kHz. So this is the circuit area they want you under, the inductance, inductive reactance section. And they tell you that here. You put your signal generator in. You got to put your jumpers in correctly to complete the circuit that they're laying out here. So you gotta put this jumper in and get the signal out to R1, and then you're going to put the jumper in from L1 to L2, and then you should already have R2 jumpered out, or at least put the post in for jumpering out R2. I'll talk about that in a moment. So then once that's done, since they want 10 volts peak to peak, 1 kHz, I already got it set up, right? You got your signal generator at 1K. I made the adjustments. The OScope is saying it's at pretty much 1.009 kHz, and they want 10 volt peak to peak. I've got 10 volt peak to peak. Remember, always use your auto set. Make sure the display is nice and clean. And again, I'm reading 10 volts peak to peak, 1 kHz. Okay? And it says, let's see what else it says. Now we're going to move on. It says remove the 2-post connector on R2. So now we're going to remove the 2-post connector on R2. Now R2 is in there. It's only a 10 ohm resistor, and it's really in there so that we'll use the OScope to measure current. Remember, the OScope only measures voltage to ground. So by putting the OScope on this side of R2, and then the other side is the common ground, I can measure the voltage drop, since it's on one side of ground, on R2. So I'm going to measure the voltage. If I know the voltage and I know it's a 10 ohm resistor, I can solve for the current. This is inferring that the 10 ohm that I'm putting in the circuit is not impacting the circuit sufficient enough such that my current is going to be wrong. So what do you want to do? It says remove the 2-post connector across R2 and use the OScope to measure the peak-to-peak voltage across R2 and calculate the total circuit current. So now I would take my signal off the generator because I got that all set, and I'm going to need a post. Let me grab a post. Bear with me. I'm going to put this post on R2, and I'm going to measure the voltage. I'm going to hit auto set, and let's see what we got. We got an AC sine wave, because that's everything is in this is AC sine wave. But this thing is reading, right now it's reading 180 millivolts. So 180 millivolts divided by R2 is 10 volts should give me what? 18 milliamps. Let's see if we're okay with that. And it looks like we're okay. So everybody see what I did, right? I took the measuring the voltage drop on R2, again, on one side of R2 to the other side. I just moved it to the post on the generator. It's the same common line. And I measured the voltage drop on R2. Remember, auto set, because you're going to a very low reading. That's why I have my probes on ×1. Make sure you remember to verify your probe is 1 times the, on channel 1 on the OScope. You got to match the probe to the OScope. And I was reading about 180 millivolts. Voltage divided by the resistance will give me the current. The resistance on R2 is 10 ohms, so the correct answer I put in was 18 milliamps. One thing about lab volt, just a quick reminder, I'm sure you've heard me say it, but if after 3 tries it's going to tell you you're wrong, you need to call your instructor. If you hit the insert button on that the cursor insert, and hit the insert button, it will give you the nominal value. Okay? So all that being said, let's see where else we're going. Now it says put the post back. I'm going to put the jumper back in there. But notice what it says now. Place the two post connectors center to R2. In the next few steps you will use the add invert method to measure the voltage drop across R1. Notice R1. I can measure voltage to ground, but I want to now see what is the voltage on R1. I got to measure the voltage on one side of R1 and compare it to the voltage on the other. So let's see how we're going to do that. It talks about an add invert method, so let's see what we're talking about. Now it says connect both OScopes. It says times 10, but I'm going to leave them on times 1. I find it's much more successful on times 1. It's got channel 1 on one side of R1. And let's see, we'll have to clip it. Don't forget your ground connector. And I got it on this side of R1. And we're going to hit channel 2 on the other side of R1. And to ground. So now I've got the OScope, 2 channels, channel 1 on one side of R1 and channel 2 on the other. Notice what I would, now remember the blue is channel 1. I'm going to set I'm going to try and set them at the same vertical scaling so you can get a sense of what's going on. I'm going to shove them, I'm going to put them on there so we can take a look at what we got. So I've got channel 1 at 5 volt scale and channel 2 on 5 volt scale. Now notice the voltage on one side of R1 is that generator output. So I've got pretty much 10 volts. Remember that 10 volt peak to peak. I've got 10 volts on channel 1 on one side of R1, but then the voltage drop on R1 drops significantly down to, and let's take a look at channel 2 is running about 2 volts peak to peak. So I'm going from about 10 volts to about 2 volts. So I got about an 8 volt drop across R1. Okay, so, but I have it all set up. Let's go on. It says set both channels vertical input to 0.2 division. Like I said, I've got it at 5. I don't know if we can get it on 0.2. Let's just, that's probably not 0.2 but 2 volt. I think that's a typo. Let's go ahead and go to 2. That looks a little cleaner. So we'll go to 2 volts. Again, that's a typo. That should be 2 volts per division. And it says set the vertical mode to add. So it says for channel 2, you select channel 2. Down here on the bottom it says invert. You set it to on. And let's see. And the vertical mode to add. And what you're doing now is you're leaving channel 1 alone. You're inverting channel 2. And you're going to go into a math function that says we're going to add those two together. So we invert. We do the source is channel 1 to channel 2. Now the red signal is actually the math. The math between inverting channel 2 and then adding the 2 channels together. And let's see. And now it's asking what is the peak-to-peak voltage on R1. Okay, let's see. Let's go to measure. I'm measuring math. It says peak-to-peak is 8.72. Hold on. 8.72. And we got a good number. If I see what we did, we can't measure directly across R1, so we've got to take the voltage to ground on both sides of R1, and there's a function. Yeah, I think the video stopped after 10 minutes. So we did the invert, and then we did the add function. What I wanted to show you is you could actually just go back to channel 2, take the invert off. So you just got channel 1, channel 2. You can go to your math and then just do a subtraction. So you're just going to subtract the 2, and you'd get that same 8 point here. I'm getting 8.56, 8.6. So you don't really need to do the invert and add with this OScope. You can just subtract channel 2 from channel 1, and then the math will show you the difference. And again, it's really just doing the vector analysis and determining now you're determining the potential difference across R1. Again, the OScope cannot measure differences in potential, only voltage to ground. Okay?